Alright, this will be our short video for lesson 11.5. We'll talk about similar areas. Now, we're going to start by reviewing a couple things, some vocabulary terms, but this video will be a little bit different. You'll be pausing the video a lot to try and do some work on your own. I'm not showing you as much other than showing you the answers you should be getting, because we're just doing area, but then we're connecting the area of figures that we know to be similar. Okay, so first of all, I want you to try and answer these questions. You might need to look up these terms in your vocab book. You might need to go back and look them up in your textbook or something, or Google them, whatever you want to do to look these up. But I want you to answer these two questions. What does it mean for two shapes to be congruent, or two polygons? And then what does it mean for two shapes to be similar? Okay, look those up. Have you looked them up yet? If not, please do. Okay, you should get something along these lines. Okay, so again, pause the video if you haven't had time to do that. But once you're ready to continue, this is what you should have. Shapes that are congruent have same size and same shape. Okay, but if they're similar, they have proportional size, but same shape. Okay? So that's kind of the difference. We're focusing on similar figures today. So here's what I would like for you to do. On number 3 here, to do some discovery on your own, I want you to calculate the area of each of these rectangles. They are rectangles, which are also parallelogram. Remember, the area equals base times height. Okay, so find the area of those two. Pause the video to give yourself enough time to do that, but you should be able to do that and just plug them into your calculator. Okay, the area of this smaller rectangle is 2 times 6, which is 12 square meters. The area of this bigger rectangle is 4 times 12, which is 48 square meters. Now, these are similar rectangles. I'm telling you right now they are similar rectangles. The side lengths of the second rectangle, you'll notice, are twice as long, or 2 times as long as the first. 6 times 2 is 12. 2 times 2 is 4. Okay, so we're going to take our sides and multiply by 2. But to go from one area to the other, we do not take our sides and multiply by 2. What do we multiply by? Sorry, we take our areas and we don't multiply by 2, we multiply our areas by 4. 12 times 4 is what gives us 48. Okay? So our area of 12 multiplied by a factor of 4. The area of the second triangle is 4 times as big as the first, or rectangle, rectangle is what we're working on. Alright? Okay? So let's try and take a look at number 4. We again have two similar rectangles. I want you to find the area of both. Okay, remember area is base times height, and this is what we should get. The area of the first rectangle is 6 square meters. The area of the second is 54 square meters. So once again, you'll notice that we change our sides by a certain factor. In fact, we take our sides. 2 turns into a 6, so that is multiplied by 3. Okay, and 3 turns into a 9, so that is multiplied by 3. So we take sides and multiply by 3. So the side lengths of the second rectangle are 3 times as long as the first rectangle. But the area isn't multiplied by 3. The area is multiplied by 9. To take a 6 and turn it into 54, you have to multiply by 9. Okay, so this new area is 9 times as much as the previous area. Okay, let's finish by looking at these triangles. Now, there is a little bit of difference here with these triangles. This 2 meters is not this side. Okay, we're going to think of the 2 meters as your height of your triangle, just like on this one, the height is 8. Because area formulas for triangles use heights. Okay, so that is the h, and that is the h, okay? Otherwise it's going to be a lot harder. So just want you to find the area of each one. Remember, the area formula for a triangle is base times height divided by 2. It's half of base times height. So go ahead and pause the video so you can find those areas and then try and answer these questions. Alright, this is what we should get. The area of this first triangle should be 3 square meters. The area of this triangle should be 48 square meters. Okay, the side lengths of the second triangle, you'll notice, we go from a side length of 3 to a side length of 12. And then, even though they're not sides, the heights go from 2 to 8. Those are still those dimensions. So the side lengths are 4 times as long as the first triangle. But the areas go up by a factor of, what is our factor here? If I took 3 and multiplied it by what to get 48? Okay, you should know that answer. And really, you just do 48 divided by 3, and we know that we have to multiply it by a factor of 16. Okay? So to answer this question at the very bottom here, it says, what is the relationship between the side lengths and the areas of the similar shapes? I want you to look at these blanks that we've filled out here, here, and here. Notice that we take the side length number that we multiply all the side lengths by, and we can use that number to get this number that changes the area. So 2 becomes 4, 3 becomes 9, and 4 becomes 16. You should notice that that amount that we change the sides by is squared to get the amount that the area changes by. So here's what I want you to write. The relationship between the side lengths and the areas of similar shapes is this. If sides are multiplied, sorry, it's an I. If sides are multiplied by some factor s, then the areas, and this is all of similar shapes, are multiplied by that same factor s to the second power, because you're multiplying by s twice, and so you're multiplying by s squared. We're multiplying by 4 for the base and the height. We multiply 3 by 4 to get 12, and we multiply 2 by 4 to get 8. Since we multiply both of these by 4, we're multiplying our area by 4 twice. 4 times the base and 4 times the height. So 4 times 4 is 16. 4 squared is 16. Okay? Okay, and that leads us to the back. So here's our conclusion. Here's a way we can wrap this up. If the scale factor from one shape to another is 5, then the scale factor of their areas, remember, is that to the second power, which is 25. Okay? If the scale factor from one shape to a similar shape is 10, then the scale factor of their areas, what is that? Should be 10 squared, which is 100. Okay? So let's practice these. I'm going to let you try and do these practice problems on your own. Okay, I've given you these. Okay, I'll work through probably one of these with you and let you try and go back and figure out the other one. Okay. The scale factor of the triangles below is 30 over 20, which simplifies. You do want to always reduce your fractions. Okay, what could that simplify to as a fraction? That'd be a 3 over 2. 30 over 20 is the same as 3 over 2. So the ratio of their areas would be 3 over 2 squared. Okay, so here's how we did that. We have one side being 30, the corresponding side is 20. So that's a 30 to 20 ratio, which is 3 over 2. So I want you to find the area of the second triangle using that information. I don't actually want you to use any calculation with your formula because they give you this area. So basically we're setting up proportions on all of these problems. Okay? So I'm going to use this scale factor for areas. Okay, I'm going to use a 3 over 2 squared. So I can actually square top and bottom. That would give me 9 over 4. Okay, so this is what I'm going to set that equal to come up with my other area. So you just have to figure out in your proportion, is this 200 square inch area going to go in the top part or the bottom part? Well, answer this question for me. Which of these two triangles is going to have a bigger area? This one, right? It's a bigger triangle. It'll have a bigger area. So that unknown area A needs to go in the bigger spot in our proportion. 9 is bigger than 4, so that's the top spot in the other fraction also. is our unknown area A. So the known area 200 goes on the smaller spot in the 200 in the bottom. Okay? And so then to solve this, we simply cross multiply. 4A equals 9 times 200, which is 1,800. Then divide both sides by 4. And so this is how we used a proportion to get our area here of 450 square inches. Okay? Why don't you try these next two? Go through and fill in these blanks as you go and try and come up with your answers there. All right? All right, these are the answers we should get. Okay? The scale factor of the sides, if we compared them, would be 11 to 44, but that reduces to 1/4. Okay, 11 over 44 will reduce to 1 over 4. So the scale factor of their areas is 1 over 4 squared, which is 1 over 16. So that's what I used to set up my proportion. 1 over 16 equals the smaller area over the bigger area, so 20 over A. If we cross multiply, A times 1 is just A, and 16 times 20 is 320. So the new area is 320 square meters. But to find the answer here, x is a side length. So here we're given both areas, and we have to work backwards and find out what one of the sides is. So here we're going to kind of take a different approach. The scale factor of the areas, I chose to go big back to small, is 360 over 10. Okay, which does reduce to 36 over 1, or just the number 36. So that's the scale factor of the areas. 36 over 1 is my blank over 1 squared, not x, I shouldn't use that, my s. My scale factor of their sides squared. So I take the square root of that, and I realize that the scale factor of the sides is just 6 to 1. Okay, this big one is 6 times the small one. Well, that's easy to see. 12 is 6 times 2. You can set up your proportion and see it also. 6 over 1 equals 12 over x. So x has to equal 2 feet. All right, that wraps up our lesson on similar areas. We'll talk more about this in class on Monday. Remember, you do have a quiz on Friday over lessons 11.1 through 11.3. All right, good luck to you, and we'll talk to you soon.